Okay, good evening to all of you. Welcome to my channel. So today I will discuss about the new topics like metal carbonyls. This lecture will go into two divided lectures. So in this topic I will discuss about the some basic introduction of metal carbonyl and classification of metal carbonyls and um, and bonding of metal carbonyls, and little bit I will discuss in this lecture back bonding synergistic effects. Okay, so if you are new in my channel, so please subscribe and like the channel and share this video with your friend and click the bell icon so that you will get new videos notification time to time. Okay, so now we'll start. So basically the metal carbonyl is discuss about metal carbonyl. Metal carbonyl. So what is metal carbonyl? So what is metal carbonyl? It is basically the low oxidation states, and mostly oxidation state is 0, but sometimes it shows -1 and +1. So points its oxidation state metal carbonyls of metals shows basically 0, -1 and +1. And these metal carbonyls are quite stable with respect to dissociation, substitution and oxidation. This metal carbonyl is little bit stable due to the dissociation, substitution and oxidation. And these carbonyl bonds to single metal or it may act as a bridge between two or more metals. This ligands coordinate to the metal is generally according to the with a 10 electron rule. So this is third point is very important. This CO coordinate with metal, it undergo 18 electron rules. So what is 18 electron rules? As I told in my previous lectures, so 18 electron rules is when any complex is given in organometallic, then that complex will follow at 10 electron. So valence electron should be at 10 if the complex is stable, and if not stable, then less than at 10 it will be, or greater than at 10 electron. So it undergoes like dissociation, substitution and oxidation. That's why the complex is little bit less stable. So these types of metal carbon followed the almost 99% at 10 electron rules. Means in these types of metal carbonyl follow 99% of metal carbonyl. Metal carbonyls follow the at 10 electrons rule. Okay. So now I will go the classification. So this is the basic introduction of metal carbonyl. I will go the classification. So what is classification? So classification of metal carbonyl. Classification of metal carbonyl. So classification of metal carbonyl. So what is metal carbonyl? What is the classification of metal carbonyl? So it is basically the two types. First, on the basis of ligands, and second we can classified, or they have classified on the basis of numbers of metal atoms and the structures of metal carbonyls. So first, on the basis of metal, on the basis of ligands, on the basis of ligands. Inside this, a homoleptic carbonyl complexes, homoleptic carbonyl complex, and number B, heteroleptic carbonyl complex. Inside this homoleptic carbonyl complex, it is like when a metal bonds to only few ligands, like example NiCO का whole 4, chromium CO का whole 6, and iron CO का whole 5. So these are the homoleptic carbonyls complexes. Now we will discuss what is the heteroleptic. So heteroleptic is basically the when a metal is bound to CO as well as other ligands such as examples NiCO का whole 3, PPH 3 all thrice molybdenum CO all thrice PF3 all thrice etc. These are the examples of heteroleptic complexes. Now second I will discuss on the basis of numbers of on the basis of numbers of metal atoms and structure of metal carbon. Second, on the basis of metal atom and a structure of metal carbonyls. So inside this they have also divided into two parts. First, on the basis of mononuclear metal carbonyl, and second, polynuclear metal carbonyl. Polynuclear metal carbonyl. Polynuclear metal carbonyl and mononuclear metal carbonyls. So what is mononuclear metal carbonyl? It contains only one metallic atoms and do not contain any CO bridging ligands. So it is example like Ni, CO, K4, chromium, CO, K6 and iron, CO5. These are the example of mononuclear metal carbonyls. So what is the another polynuclear metal carbonyl? It contains two or more metals atoms, contains two or more metal atoms, is known as polynuclear metal carbonyls. So okay, so now we will discuss about the another classifications like homonuclear. Discuss about another classification inside this. First, homonuclear metal carbonyls. Second is heteronuclear metal carbon. So what is homonuclear metal carbon is? So homonuclear metal carbon is, it also contains metals atoms of only one elements, like examples of Fe, CO, 9, Mn, 2, CO, 10, CO2, CO, 8, etc. And heteronuclear metal carbonyl contains metals of different elements, like examples, if you choose these examples only Mn. There are several examples, but I choose this 4. So these are the heteronuclear metal carbonyls. Okay, so now I will come to the another parts, bonding in metal carbonyl. Bonding in metal carbon. So here you should remember some points. First, CO is a good sigma donor as well as pi acceptor, ligands. Okay, there are some pi acceptor like cyanide, NO, C2H4, ethane. These are pi acceptor ligand explained due to the MOT theory, MOT diagram of CO. Second point, oxygen. As we know, oxygen is more electronegative than carbon. Oxygen is more electronegative than carbon, so electronegative. That's why the energy of orbitals of oxygen are lower than that of carbon. The energies of orbitals of oxygens lower carbon. So these 2 points is very important if we draw the molecular orbital structure of this CO. So if I erase these things, then I will start. Okay, now I will draw the MOT structures of this diagram of CO. So if take this side carbon and this side oxygen. So as I mentioned in points, the oxygen is more electronegative than carbon, so that energy orbitals of oxygen we should write in we should mention in lower energy. Okay, so oxygen energy will be lower, so energy of oxygen will be lower for oxygen this, and for carbon it should be little bit higher, like this. Okay, so this is 1s for oxygen, this is 1s for carbon. And now another orbitals of oxygen is 2p. This is for 2p, and this is here 2s. So 1s2 2s2, total electron is how much? 8. So 1s2 2s2 2p 4. Here 1s2 and 2s 2s and 2p. So how much electron if we write configuration? 1s2 2s2 2p 2 means carbon has total electron 6, so we can write this. So if we draw bonding, so here form sigma bonding with sharing of 1 electrons, sigma 1s, and here this form anti-bonding, sigma star 1s, and 2s is form non-bonding, So here the 2s play a role as non-bonding electron, and 2s1 here is form bonding with this 2pz. If it is try here 2pz, this is 2pz, here the px py. So these are the orbital for px py. So this is bonding sigma 2s sharing of 1 electrons, and here goes the anti-bonding. Like this. This is anti-bonding sigma star 4. Okay. So this is the some basic diagram of CO, and other we can draw structure. Sorry, this is px py, this is bonding from here to here, this is bonding, and this is like this, and this goes like this. Okay, so this is pi star 3, pi star 4, and this is pi 1, pi 2. Okay, this is bonding, this is anti-bonding. Okay, and other the here also non-bonding 2pz layer non-bonding, here non-bonding. So this is the basic structure of MOT diagram of CO. Okay, okay. So now I will go little bit into direction of pi back bonding. So I will see the diagram of orbital overlapping of CO, C, triple bond C. So orbitals on carbon combined with same orbitals like C double bond O or oxygen give two degenerate pi orbitals, as I draw here two degenerate pi orbitals, and two also degenerate pi antibonding orbitals, here degenerate pi antibonding orbital. So if I see as I told you how the structure of orbitals C triple bond C how overlap. So if consider part A of C triple bond C. So if we draw the orbitals like this, this is for px, this is for px, and this is for py, px, py, and this is for pz. Okay, and similar like this. Like this. So here is pz, this is py, this is px. So how they overlap? They overlap because carbon has valence electron 4, so one electron goes this and two electron goes like this. Okay, and here is this is the vacant py orbital, vacant py orbitals. Okay, so how it will combine overlap, how it will form the bonds. So this overlap with this single electrons of px another carbon, so it will combine like this from here to here. Okay, and another remaining electron 1 here 1, this is combine this is sp jet orbital, single occupied, and this is sorry this is w occupied py orbital, this is vacant py orbitals. And now we see structure B, C triple one O. So how it will overlap? So if you see, draw this like this. So here is positive charge, here is negative charge. If you like draw like this, here is positive, here is negative. So positive overlap and negative will overlap. So it will form the CO pi star orbitals. So little bit I am moving in direction of pi back bonding. So if we take the like of metal carbonyl, so how it will overlap? So if we see, consider metals, pz, px. Okay, for carbonyl C double bond O, double electrons, carbon has double electron, it will formed like this. Overlap when this bond overlap with this, then it will form like this. Carbon triple bond O like this. Okay, or you can draw like this. Okay. So this is the sigma bonding. It look like how this. It look like this. So now we will try to form the pi back bonding after pi back bonding pi back bonding orbitals. We put for metals like plus negative plus negative on this negative plus negative, so it will overlap form bond like this the pi metals, and this is CO pi star orbitals. This is back bonding. Okay, so this is the some basic introductions of overlapping of orbital structures. So now last point I will discuss in this lecture little bit about the some note points. So sigma and pi bonding reinforce, as you know, strengthen each other. Formation of sigma bond results increase the electron density of metal. Formation of sigma bond then increase the electron density on metal, and increase the electron density on metal. The positive charge on CO is increased. The pi accepting ability of CO increase. So like this, if increase electron density, then density on metal, then positive charge on CO increase the pi accepting ability, is also increase. So if we look like this, if develop this partial charge of metal and negative charge, positive charge, partial charge on this oxygen, and it will delocalize of this, so form the double bonds, and here the reduce the single bond, reduce triple to double bonds. So what happened? So electron density here metal is increased, that's why through the back bonding the order of CO is decreases, and MC bond order is increases. So second point is very important. So electron density of delocalization from metal d orbitals onto the pi star orbitals of CO increase due to the electron flow from CO to metal d orbital rays. Okay, so in next lecture I will discuss about the synergistic effects. So because here is time limited also is that's why I will discuss in next lecture synergistic effects, and I will cover in detail back bonding and various factor affect the stretching frequencies, and I will took some examples. Okay, thank you. So please subscribe the channel and click the bell icon so that you can get the notification. So okay, bye bye, good night.